Hello and welcome to part 2 of this week's exam marking video. This next question is about a large drill that's used to excavate for oil. So basically to drill very deep down into the earth to try and find oil. The drill is water cooled as it moves through the rocks in the earth's surface. It wants you to suggest why that's the case. Now there's a couple of reasons why that's the case. So the water actually lubricates the drill. That basically makes it move easier, right? So in the same way you would lubricate an engine with oil to make the parts of the engine move easier, you could do the same maybe with a hinge on a door, or basically any kind of metal machine. It makes it move easier, and it reduces friction and makes the whole thing more efficient, right? And then the second point is the energy is transferred, so there is energy transferred to the thermal energy store of the water. That cools it down. So when the drill gets very hot, because it's been moving a lot and there's lots of friction there as well, the energy is transferred to the thermal energy store of the water, and then the water evaporates, and that actually cools the drill down. Okay, next point, a calculation question. I have started bugging here. We've got our gravitational potential energy boxed, got our mass, got our height, we've got gravitational field strength as well. So we've got all the values there. Let's just list them by the side to make things really clear and think about our units. Here we've got the mass, we know the gravitational field strength, and we know the height as well. Here's our equation, mgh, substitute in, that gives you 86,240 joules. I've written that there. You may want to do that as three significant figures. As three significant figures, you would underline 3, circle, and then decide that's lower than 5, so it would be 86,200 joules in total. You need to have all of that, including the unit, for 3 marks. You get 1 mark for this step, 1 mark for an answer of that, and then 1 mark for the unit. Okay, next one, another calculation, kinetic energy store this time. I've boxed that, that's our kinetic energy. We've got a mass and we've got a velocity, so we've got everything we need. I've listed that down here. Kinetic energy, we don't know, but the unit's joules. Mass 2 kilograms, velocity 8.6 meters per second. We've got the equation, substitute it in. Remember, it needs to be a half times those two values. Joules as a final answer. Again, if you want to do it to 3 significant figures, I think that's better. 46 points, underline, circle, decide, 2 joules. Okay, in the same way you get 3 marks, 1 for this, 1 for 46.2 and 1 for joules. Okay, 3D, the correct answer to this is that the gravitational potential energy of the weight at the top is the same as the kinetic energy at the bottom, because all the gravitational potential energy in that store of the weight transfers to the kinetic energy store, so it all transfers and none is lost. That's to do with the law of conservation of momentum, the law of conservation of energy. So no energy is created or destroyed, it's only transferred. Okay, last question. I did quite like this question actually. You can do a simple comparison quite easily, but I'm going to take you through a more complicated comparison, but it does combine things that you've already learnt about. Alright, so we'll quickly just read through it. Once you compare an electric bicycle and a normal bicycle on a 5k uphill route. The cyclist doesn't pedal when they're using the electric bike. I guess that's kind of the point. And we've got some information here. We've got the power of the motor. Obviously there's no motor in an ordinary bike. We've got the force to drive the bike forward. So in the ordinary bike, this force is coming from the person, the rider. We've got the weight of the bike, the battery life, obviously no battery in an ordinary bike, and the time taken to travel. So the electric bike is a little bit quicker, but not much quicker really. So the cyclist on the normal bike, let's start by looking at that, right, or the ordinary bicycle. It's less powerful than the motor. I'll show you how I work that out, right? There's the equation, work done equals force times distance. So we've got the force here, it's 47 Can you see that? 47. I can just write that again there. 47 newtons. And you have to multiply that by the distance, and if you do that you'll get a number which is pretty big, 235,000 joules. So that's the work done by the ordinary bike, right? You can then work out the power of the ordinary bike as well. So if you did power equals work done divided by time, we've got the time, 13 minutes. That needs to be converted into seconds, so you times it by 60. That would give you, I'm not sure exactly, but you know, quite a large number, definitely in the thousands. And if you pop them into the equation, work done divided by time, you would get the power of the ordinary bike, which is 301 watts. I've done that to 3 significant figures. So I've actually worked out the power of the ordinary bike here, 301 watts. So you can compare the two powers. Actually, the electric bike uses more power, right? It's 350 watts. So this is the level of, you know, comparison that you need to be going in to get 6 marks. You know, if you just said things like, you know, the weight of the electric bike is more than the ordinary bike, you know, the electric bike or the is a bit faster than the ordinary bike, those kinds of things, you know, you might get 1 or 2 marks, but you need to be applying your scientific knowledge in you know, an interesting and, you know, thoughtful way in order to get lots of marks. So this is the kind of thing you need to do to get 6 marks here. You know, I've put a point at the end as well. I've said, you know, more overall power is required, I mean by the electric bike, because it is much heavier. So I've even come up with a kind of judgment, a kind of conclusion there as well. So like I say, you need to be going into a lot of detail to get 6 marks there. A simple comparison is really just good for 1 or 2 marks. You need to use your judgment on what you've done. You know, do make sure you've got all of this working down. It is important. It combines important equations: the work done equation, the power equation, and, you know, try with these 6 marks questions. You know, try to make your own kind of you know, judgment or analysis at the end of it as well. Yeah. All right. I'll leave that there. Thank you very much.